Welcome to how to deploy a Dockerized Fast API to Google Cloud Run, CI/CD included. This video is the culmination of years of struggle and sauce, and you'll be fast tracking your way to web development success if you pay attention closely. I suggest first watching this video all the way through to understand its overall message, and then returning to individual sections as needed. This tutorial is in 4 parts. In part 1, we will create a dev container. In part 2, we will build a simple fast API. In part 3, we will deploy the API to GCR. And in part 4, we will set up CI/CD. So sit back, enjoy, and if you want to follow along with the code, I've included a link to a GitHub repository in the description. Development containers are a specification being developed at Microsoft that allows you to attach your IDE to a Docker container containing your development environment. At the time of recording, the only IDEs that have solid support for dev containers are VS Code and IntelliJ. So if you don't use these IDEs, this video is probably not going to be too practical for you. To easily follow along, you'll need at least a rudimentary understanding of the following tools/concepts: Docker, Docker Desktop, VS Code, i.e. the world's most popular application for editing code, VS Code extensions. Particularly, you will need the Docker extension and the dev containers extension. Installing these extensions should only take a few clicks and a few seconds. And also general software development concepts like Git, CLI commands, APIs, and programming languages will definitely help you out with following along. Here we are starting with an empty folder on our computer. Let's start by creating a .dev container folder at the root of our project. Inside of this folder, let's create an empty file called devcontainer.json. What should we put in this file, you might ask? Well, if we take a look at the official dev container spec, we'll see all of the individual keys we could specify, but to get us moving along, I'll just paste in this JSON content right here. This devcontainer.json file is where we specify the details of our development container. The name key is where we specify the name we want to give our dev container. This is arbitrary. The build key is where we put the reference to the Docker file that will act as the base point of our development environment. This will make more sense later. The customizations key is where we can customize many things. Here we're customizing which VS Code extensions we want installed into the VS Code instance that gets attached to our development container. Line 18, I don't think we need, but I put it here because it doesn't hurt. This is where we can specify which ports on our host machine will get forwarded to ports on our container. The workspace mount is where we specify the location inside of the development container that our project files will get mounted into. On line 22, we have a key that says workspace folder. This is the folder that will get opened by default when we open our development container. And on line 23, we have an empty run args array. This is where we can specify some further customizations that we're not going to need for the moment. Next, we'll add the Docker file referenced on line 4. This will give us most of the software we need for our development environment. And I will populate this file with the following content. You remember how I suggested you install the Docker VS Code extension? This functionality where you can right-click and inspect what's going on is powered by that extension. We're using 312 Slim. Anyways, in this tutorial, I'm using VS Code, so I'll show you how I like to open the development container. There are other techniques for doing so, like running scripts to open it, or you can follow other techniques that use other IDEs, but like I said, I'm just going to show you how to do it with VS Code for now. Shift-Command-P. This will open up the command palette, as it's so called. And I can locate an option that says Dev Containers Reopen in Container. I will select this by pressing Enter. And now our development container is being built. If I pull up Docker Desktop, we can see that we currently have no containers that are registered with this application. After the development container has been built, we will see it listed here.
2 very boring minutes later.
Okay, that took about 2 to 3 minutes for me. Note, the first time you run a Docker container, it will tend to be very slow. But as Docker caches a lot of files on your behalf, subsequent runs of your container will tend to be faster. Also note, if for some reason you have to edit either the dev container specification or the Docker file, you will probably need to rebuild your development container and take that 2 to 3 minute hit of wait time where you're waiting for the container to be rebuilt. Also note that we are using a specific version of a Python container called Python 12 Slim. This is a version of a Python container that gives us Python, but strips out a lot of unnecessary files in order to keep our development environment super lean. Let's quickly smoke test this development container to make sure it's legit. Let's check and make sure we have Git installed. We do. Let's make sure we have curl installed. We do. Let's make sure we have Python installed. We do. And let's double check which version of Linux we're using. Debian. So at this point, we have pretty much most of what we need to develop any Python application. Setting up this dev container is the first step in our larger goal of deploying a fast API to GCR. What we're really doing here is A, building something cool, and B, sharing it with the world as quickly, cheaply, and simply as possible. We'll continue in the next sections by building the fast API, deploying it to GCR, and then setting up a CI/CD pipeline. Now we are going to build a simple, fast API. Remember, the focus is not building some crazy API here, but rather learning the overall process of how to deploy Dockerized containers to GCR. Setting up a fast API just entails adding some files and folders to our project. I will speed this up to not bore you. Notice how we have these warnings on our imports, and the warning says something along the lines of import could not be resolved. This is because we have not yet installed our packages. So let's do that really quick. Notice that after we install our packages, the import warnings go away. Let's run 2 quick smoke tests to make sure everything is working. So let's run the fast API and open up a new terminal, and let's hit an endpoint on the fast API, make sure it's working. Hello world, fantastic. Now let's also make sure that our breakpoint debugger works. So let's add a integration for VS Code's breakpoint debugger, and we want to remotely attach to our debug server listening on port 5678. Fantastic. Now let's run the breakpoint debugger. And if we put a breakpoint here and hit the endpoint again, it pauses on our breakpoint. So debugging works as well. So everything is looking great. Now that we have our API developed, let's ship it to the world. We have now arrived at the meat of the matter, i.e. deploying a containerized fast API to GCR. Let's install GCP CLI into our development container. Here is the new version of the development Docker file. You can look through it and see that it will install gcloud, which is GCP's CLI. This is a change to the Docker file, so we will need to rebuild our development container. How do we do that? We type Shift Command P and reload window. After doing that, you should see the dev containers extension pick up that there was a change to the Docker file. You can click this rebuild button. If you're wondering how I figured out the instructions of how to install gcloud onto Debian Linux, what I did was search the webs, and I found this documentation on GCP with pretty clear instructions for how to install gcloud onto Debian Linux. After our dev container has been rebuilt, we can run this smoke test to confirm that gcloud has been installed. And indeed it has. When you're working with GCP or any cloud provider for that part, you want to stay organized. And the suggested technique for doing this is to organize the resources you provision into projects. So let's create a project and we'll call it How to Deploy a Fast API to GCR. We'll click Create, and we'll be able to easily delete all of the resources we provision by simply deleting this project. So we'll select this project. The next thing to do is authenticate our dev container with our GCP account. So the way we do that is by typing gcloud init. Yes, I would like to log in. It'll spit out a URL that you can go to in your browser. I will choose my account, type my password, accept, and then I will eventually be given a verification code that I can use to authenticate my dev container with GCP. Then I will select the project that we just created. And now our dev container is set up to provision resources in this hyphenated project that we just created. As perfect as our development container is, for several reasons, it's not quite suitable for production. So what we'll do now is prepare our application to be deployed, starting by first creating what's called a repository in our GCP account. Our repository is a place where we can store our images. To give you an analogy, if you're confused by this Docker lingo, the Docker file is sort of like a blueprint. We will read the instructions in our Docker file, and that will leave us with what's called an image. An image will be a deployable version or runnable version of our application and all of the dependencies it requires, including its OS requirements. Let's check out our Google Cloud Console and go over to the artifact registry, enable it for our project. This is where we will be storing our images. Now let's create a repository that will store all of the images for the production versions of our application. Here's how we do this. Great. And now if we reload the console, we see we have a repository created in our artifact registry. Let's now create another Docker file in our project. This one will house the instructions for how to build our application for deployment purposes. This one is called dockerfile.prod, and this is the content that we will populate this file with. Now that we have our production Docker file, we will add one more file called cloudbuild.yaml. Now we can issue a command to GCP through the gcloud CLI that will read these instructions and build our Docker file in a way that's compatible with the GCR platform. Let's give this a spin. What you're seeing here is something you'll see often when interacting with the GCP platform. They do their best to ask for your consent before using new features on their platform. I will say yes. So let's pop over to our repository once again. I reload this. Eventually we should see our image stored here, and there it is. So once again, what we did was create another Docker file that includes the instructions for how to build our application in a way that we can deploy to GCR. We also included a file called cloudbuild.yaml. We ran the command to perform our build on gcloud. And when that succeeded, we now have an image in our repository. Now that we have our production image stored in a repository in Google Artifact Registry, we can issue a command to GCR to pull our image from our repository and run it. Let's see what that looks like. First, what we'll do is create another file in our project called service.yaml. And we will populate this file with the following content. And now let's run our application in GCR. Here is some more permission stuff. Yes, I would like to enable GCR on this project. And look at that. We've been given a URL that will allow us to interact with the deployed version of our application. So if I command click, let's see what we find. This is expected because by default, GCR services are not publicly accessible. So we have to do one last thing, update our service policy. And the way we do that is by creating another file in our project. And we will populate this file with the following content. This is a policy that allows anybody to invoke our service. So let's apply this policy to our service. And now when we load our endpoint, let's see what we find. We've come a long way. You now know how to take containers that run on your local machine and deploy them to an amazing managed service like GCR. It's quite annoying, though, to have to manually trigger a build and manually update our GCR service each time we want new code to be pushed to our endpoint. So what we'll do in the final part of this tutorial is set up an automation on GitHub so that each time we push code to our main branch, it will automatically trigger our builds and automatically update our GCR service. Let's see what that looks like in the final installation. There are many tools we could use for automating our deployments, but today we are going to be checking out GitHub Actions. This is the repository we will be using to test out GitHub Actions. If you don't already know, this repository holds a Fast API. And each time we update the code in the main branch of our Fast API, we would like to trigger an automation that will automatically deploy a new version of our application to Google Cloud Run. The process for doing this is actually quite simple. First, we need to come over to our GCP account and provision a service account, which is a fancy way of saying access credential. So we will create a service account called How to Deploy Dockerized Fast APIs to Google Cloud Run. Yes, create and continue, done. And then what we want to do is add a key, download our key. This is our password that will give GitHub the permissions to push new services to our GCP account. So we come back to our GitHub repository. We come over to the settings section and we come over to the secrets and variables section, actions, and we are going to create a new repository secret. We'll paste in our service account credentials, as it's so called, and the name of this secret will be GCP SA key. Add the secret, and the integration work of making GitHub talk to our GCP account has been completed. Now we'll specify the details of our deployment automation or our GitHub action. The way that we do this is by creating a special folder in our project directory called .github. And inside of this .github folder, we place another folder called workflows. Inside of this workflows folder, we can place a YAML file that I believe can be called whatever we like. I have called it cicd.yaml. This is the content that I will use to populate this file with. If we scan this file, we can see it consists of a series of instructions whereby we authenticate to GCP and then issue some instructions that deploy a new service to GCR on our behalf. So let's push this to our GitHub repository and hopefully it works the first time. If we come back to our repository and go over to the Actions tab, we can now see an automation is in flight and we can view the build logs in real time. Holy, it worked. So let's come to our endpoint again, which is already loaded here. And if we reload this, it's still working. Now let's do a quick end-to-end test and let's put a emoji here. Okay, we see another automation has been triggered. Okay, let's reload the service. And now we see our update. You might run into some issues with permissions between GitHub and GCP, or you might run into some permissions issues with your service account and GCP. I included some tips in the GitHub repository for how to add permissions you'll probably need. But if you run into any issues, leave a comment and we made it.